This fall, we saw Hurricane Helene bring devastation to our state. It was the worst storm to impact the state's power grid, with over 2,000 power poles snapped and over 1.3 million customers without power. It also hit the agricultural industry incredibly hard, with an estimate of $5.6 billion of losses. Now, Helene is just one of many storms to impact Georgia in the last decade. And as our climate continues to warm, science shows that rapid intensification of storms can become more common. New this week, a study by Climate Central is being released that can help quantify or put a number on how much stronger storms can be in our current world versus one without human contribution of greenhouse gases. Joining me now is one of the authors of the study, Dr. Daniel Gilford, a climate scientist with Climate Central. Thank you so much, Dr. Gilford, for joining me today.
Thank you for having me.
So first, let me start off by this. Explain to me why it's important to do this research. What was the motivation behind it?
I grew up in Florida, and I've always cared about hurricanes. As a result, they affect the communities that I care about. So I really wanted to understand, as we are changing our climate system by increasing the amount of greenhouse gases in the atmosphere, we increase the temperature of the planet. So to what degree does that increasing temperature of the planet affect these hurricanes, and what does that mean for the communities that I care about? That's why I've done this work.
So hurricane intensity, it has a lot of different facets. What did you try to look at and quantify within hurricane intensities? Because I know a lot of deaths come from, of course, the winds, but more come from the water. So why is it so important to look at the max winds on these storms?
That's right. So a while ago, there was a study that looked at how the damages of a storm relate to how intense a storm is. And we find that the sort of rate of damage increases with storm intensity. So a more intense storm, like a Category 5 storm, is generally going to have more intense impacts than say, a Category 4 or Category 3 storms, even along the coastlines in terms of things like storm surge, but also in terms of straight line wind damage or even rotational wind damage in the form of, say, tornadoes. All of these impacts can sort of ramp up as you increase the energy of the storm, which is what happens when the intensity goes up.
And how did you come to your methodology in sorting through the data? How did you do that?
Yeah, so we want to use multiple lines of evidence to either agree or disagree that climate change is influencing these storms. So in order to have those multiple lines of evidence, we've used both observations and models. With observations, we can look at what temperatures were like about 100 years ago and see, before the influences of humans on climate change, from climate change on the temperatures, how much colder were they. We can also use our climate models and run them with and without the greenhouse gases that we know human beings have emitted to the atmosphere, and see how much colder the sea surface temperatures in the North Atlantic Ocean were because of those carbon dioxide emissions not being there. So when we put these two independent lines of evidence together, we show that both of them in a world without climate change would have been quite a bit colder, sometimes up to 3 degrees Fahrenheit colder, because we have emitted greenhouse gases. We now have that extra 3 degrees Fahrenheit that we're dealing with. And when these hurricanes roll over and along, say, the Gulf of Mexico, they see that extra heat, and that allows them to bump up in their intensity.
And so you're talking about latent heat. So what people, need to understand is that hurricanes, tropical cyclones, they're like Goldilocks and the Three Bears, right? Everything's got to come together. And when you have the warmer temperatures, that's more energy for fuel for them to turn stronger, right?
That's exactly right. So you can imagine the hurricane is almost like the heat engine on a car. It needs some sort of fuel source in order to spin and rotate those wheels. The fuel source in the case of a hurricane is those warm sea surface temperatures, providing that warm, moist air to sort of energize the storm. And then it can take that energy in the form of from those sea surface temperatures and turn it into winds. And those winds are what we think about when we're thinking about the intensity.
So Dr. Gilford, you went through 5 years of data, 2019 to 2023. What was the average max wind increase with all those storms within that 5-year period?
So with that 2 to 3 degrees Fahrenheit of temperature increase along the track of these storms, we find that the storms on average increase by about 19 miles per hour. That's a little bit more than an average category on the Saffir-Simpson scale. So generally speaking, these categories, the storms that we're experiencing over the last 5 years, about a category more intense than they would have been without human-caused climate change.
Now, were there any storms in particular that had a greater wind increase than others, and why do you think that might be?
Yeah, so one storm that really is surprising is Hurricane Raphael, which we just realized just a couple weeks ago as we were doing the analysis. The storm passed through and made landfall on Cuba. And right before landfall, it was a Category 3 storm. Well, we tried to turn that analysis around as quickly as possible and came out just 5 days after the storm occurred. We were able to use our analysis to show that Hurricane Raphael, while it was a Category 3 storm, would have actually been a Category 1 storm without human-caused climate change influencing the sea surface temperatures that it experienced. That was really surprising for a November storm to have a Category 3 storm in early November. Well, we wouldn't have had that storm. We would have had a Category 1 storm instead without human-caused climate change, and that was very surprising.
So that's Raphael. Talk to me about Helen too, because I know your first research paper was on those 5 years, but you've already gone through the 2024 season. What did you find in Helen? What would the winds have been if we had not had human-induced climate change?
Yeah, so Helene is actually a storm that's around average. So we estimated for Helene it was about 16-mile-per-hour boost because of the human-caused sea surface temperature warming. So it's about a category more intense than it otherwise would have been because of human-caused climate change. So that Category 4 Helene would have actually been a Category 3. But one of the other things we know about Helene, there's some research that my colleagues at Stony Brook and Lawrence Livermore Laboratory have done showing that Helene was actually quite a bit more wet as well because of human-caused climate change. So we know that as the atmospheric temperatures get warmer, they also get wetter, and they can drop, and these storms can drop a lot more rainfall, sometimes up to 50% more along the track of the storm, as we had in the case of Helene. So not only are these storms becoming more intense, as we're showing in our study, but we're also finding in other related research they're becoming wetter.
Right, and we saw that heavy rainfall here from Helene, plus the pre-Helene rainfall event that caused flooding in Atlanta. Let me kind of end with this before we pivot in another direction. In 2 to 3 sentences, can you kind of summarize what did your study show and achieve?
For the first time ever, we can put a number on the extent to which human beings are increasing the intensity of hurricanes because of human-caused ocean warming. We know that the warming temperatures are out there in the Gulf are affecting these hurricanes, and now we can say with strong confidence that we are responsible for increasing the intensity of storms that are affecting our communities. That's what this research can show us, and we can do it in a very quick turnaround time so that we can talk about these storms as they are occurring in the coming seasons.
Now, your initial research paper that you published last month in October, it was for that 5 years. Do you feel that that's a very small data set for a much bigger chunk of how our planet has changed? Do you feel that you've quantified these numbers well enough, or do you think that more data would have helped?
Yeah, so we've focused on the analysis over the last 5 years and indeed bumped up the analysis to also go through 2024, as you mentioned. But the data underpinning that 5-year analysis actually goes back over 100 years to 1900. So the data underpinning our analysis goes back quite a bit further. We wanted to focus on the last 5 years because these are the storms that are fresh in people's memories and they're familiar with them. And so when I place, say, a Helene or a Milton, you can understand how human-caused climate change affects those. We actually have analysis going all the way back to the 1980s. I was looking at this morning and found that the human-caused climate influence here in 2023 is about 3 times as much as we had in the 1980s, but there was still a small influence from human-caused climate change in the 1980s as well, about 7 miles per hour. But now we're up to about 19 miles per hour. We focused on the most recent times because that's the world we're living in right now.
Yeah.
So any of the storms that we want to look at in the past, we can do that, especially going back to the 80s. But the more recent storms are the ones we're living with and the ones that we're talking about, and the ones that we should think about when we're trying to make decisions going forward when it comes to climate.
And this kind of research, when we're talking about actual impacts of storms, you're talking about how these storms impact people. This is the time that we're living in. We often refer to climate attribution, Why is climate attribution science, like studies like this that are putting numbers and quantifying the impacts of climate change, why is that important for communications?
Because if there's an event out there, without doing the analysis to understand how human beings have influenced it, we're in the dark as to what our influence from climate is. We know that the temperature of the planet is going up. But what does that mean for particular events? Well, that's what our climate attribution research is trying to show, to get us out of the dark, to bring us into the light of what is occurring with these storms. In the case of hurricanes, it means that storms are becoming more intense. In the case of flooding and inland flooding especially, storms and rainfall events are becoming heavier. We know that the temperatures across the planet are soaring, and we have increased heat waves as well, and we are responsible for that. Climate attribution science allows us to say, this is human-caused climate change at work in our society and in our communities. So now let's get to work. Let's start removing our reliance on greenhouse gases. Let's start working and having conversations about what we can do together on climate change.
Is there anything you want to add that you feel that we didn't cover today?
No, I think that's pretty much it.
Okay, Dr. Daniel Gilford, I really appreciate it with Climate Central. You are a climate scientist with them. Brand new research study coming out, putting numbers, quantifying how much stronger our hurricanes have been in the last 5-6 years thanks to climate change. Thank you so much.
Thank you very much.